polynomials. In this session, we will focus and learn about algebraic identities. We have studied these algebraic identities in our previous classes. Today, we will find a few more identities using these four identities. So, let's begin. Identity 1. Using the identity for the square of a binomial, we will derive the identity for the square of a trinomial. So let's apply identity 1, x plus y square is equal to x square plus 2xy plus y square to a trinomial x plus y plus z to the whole square. Here, if we assume x plus y as t, then this trinomial identity can once again be seen as a binomial identity. You can also assume y plus z or x plus z as t. Our goal is to convert it from a trinomial to a binomial. Now, we can use identity 1. And now, keep the value of t. Then you will get this. X plus y plus z the whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. We can remember it like this. In the square of a trinomial, there are 3 squares and 3 factors. And this is called identity 5. Just like we learned how to derive the identity of the square of a trinomial from the square of a binomial, we will now learn to derive the identity of a cubic polynomial from a quadratic polynomial. So, let's compute x plus y to the power of 3 by applying identity 1. We can write x plus y to the power of 3 like x plus y into x plus y to the power of 2, which becomes x into x square plus 2xy plus y square plus y into x square plus 2xy plus y square. When simplified, this becomes x cube plus 3x square y plus 3xy square plus y cube. Or you can write it like this as well. X plus y to the power of 3 is equal to x cube plus y cube plus 3xy into x plus y. And this is identity 6. The next identity is based on this only. We have to find the extended form of x minus y to the power of 3. We can derive this by substituting y with minus y in identity 6. And let's call it identity 7. And now let's move towards the last identity of this session. X plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. It looks a bit different in its extended form. So after this step, some terms cancel each other, leaving only x cube, y cube, z cube and minus 3xyz. And this is our identity 8. If you notice, we have expanded the right hand side to equal the left hand side. You can write this in any order. Friends, can you tell us why we use identities in the study of polynomials? These identities help in finding the factors and multiples of algebraic expressions. And we will see similar examples in the next video. So what did we learn in today's session? We learned about algebraic identities. And now we will solve some questions based on algebraic identities. We have a total of 8 identities. By using these 8 identities, let us see how to find the factors and products of polynomials. So, let's start with our first question. Find the product using the appropriate identities. By looking at these 8 identities, can you tell which one can be used to solve this question? To find the answer to this, we will have to see to which identity this question resembles. That is, in which identity there is a sign of addition and subtraction between two terms. And that is identity 3. X square minus y square is equal to x plus y into x minus y. That is, 2x plus 1 by 2 into 2x minus 1 by 2 is equal to 2x square minus 1 by 2 to the power of 2. After solving this, we will get 4x square minus 1 by 4. Now, let's find the solution to another sub-question in a similar way. All identities are related to the addition or subtraction of two terms. If we write it in the form of 100 plus 7 into 100 plus 5, it will look like identity 4. X plus a into x plus b is equal to x square plus a plus b into x plus ab, where x is 100 and a and b are 7 and 5 respectively. So 107 multiplied by 105 would be 100 square plus 7 plus 5 multiplied by 100 plus 7 multiplied by 5, which becomes 10,000 plus 1,200 plus 35. That is in total 11,235. Let's move to the next question. Find the factors of 9x square minus 6x plus 1 using the appropriate identities. Which identity does this look like? Can you answer? In such cases, pay attention only to the variable, that is x square minus x plus dash. Doesn't this look like identity 2? If we write it like this, 3x square minus 2 multiplied by 3x plus 1 square, then this becomes equal to 3x minus 1 to the power of 2. Let's go ahead and take the next question. Expand 2 by 3y minus 1 to the power of 3 using the appropriate identities. Here we have to use the identity directly, where x is 2 by 3y and y is 1. Pause the video and try to solve it yourself. The solution will be somewhat like this. Now write 1 by 2a minus 1 by 3b plus c whole square in an expanded form. Here, which identity will we use? Yes, identity 5. Here, x is 1 by 2a, y is minus 1 by 3b, and z is c. This is quite easy. Solve it yourself and see whether you are getting the right answer. Let's take the next question. Find the factors of x square plus 4y square plus 9z square minus 4xy plus 12yz minus 6xz. Once again, we will look only at the variable and all the identities and find out with which identity it resembles. If we write this expression only in terms of x, y and z, then it will look somewhat like this. And now we will write it as identity 5. Now this will happen, which we will write in factor terms as follows. And now let's take the last question of this session. The area of the given rectangle is as follows: 32x square plus 6x minus 5. Give the possible expression of its length and breadth. Friends, the area of a rectangle is length multiplied by breadth. The area of a rectangle is a quadratic polynomial. After finding its factors, we have to substitute it with the length and the breadth. This means we have to find the factors of this polynomial. We will solve this polynomial 32x square plus 6x minus 5 by splitting the middle term method. So 32 multiplied by minus 5 will be minus 160. Now two numbers whose product is minus 160 and the sum is 6 are 16 and minus 10. Now let's write it like this. 2x plus 1 and 16x minus 5 are the possible expressions of the length and breadth of this rectangle. So friends, that's all in today's session. In today's video, we learn to solve questions based on identities. Today we will discuss some questions related to algebraic identities. Find the value of 98 to the power of 3 using the appropriate identities. You must have seen such questions. How would you solve it? Generally, we write such questions in this form: 100 minus 2 to the power of 3. Can we also write it like this? 90 plus 8 to the power of 3? Yes. When we write it as 100 minus 2 to the power of 3, then the identity x minus y to the power of 3 is used. And for 90 plus 8 to the power of 3, we will have to use the identity x plus y to the power of 3. Pause the video and try to solve it yourself. Using both methods, we will get the same answer. The only difference is that using the number 100 makes it a little easier to multiply or square or cube. So friends, that's all in this video. See you in the next video with a new chapter. Thank you.